Welcome, Wildcats. Today we're going to be taking a look at the next section of Unit 10, which is 10.3, the properties of logarithms. Now you guys might remember back a while ago, you talked about the different properties of multiplication, division, addition, and subtraction. Things like the associative property of multiplication, which basically said that it didn't matter which order you multiplied in, 10 times 6 was the same as 6 times 10. We're looking at some of the same things now for logarithms, but because it is a slightly more complicated and advanced item, it is going to be slightly more obnoxious to work with. But let's take a look at it. So first, we want to look at a couple of the definitional properties. For example, if you have log base b of b, so the log, as long as what you're taking the logarithm of and the base are the same number, if that's raised to a power, that's just whatever that power is. So if you have log base 4 of 4 raised to the 10th power, that's just going to be 10. That is a definition of logarithms. There's nothing I can show to prove that to you. It's just the definition. That's what it is. Along that same vein, if you have log base with any base of 1, that equals 0. The reason for this is because any number raised to the 0th power is just 1. A corollary to that then would be the log of any number, as long as the base is the same as the number, is just 1. So log base 4 of 4 is 1, because 4 raised to the first power is 4. You can see that that third one kind of follows both from the second and the first. The power of b in that third line is just 1. So m is 1, and our answer is 1. These definitions will get you started on a lot of these problems, but they don't have a lot of power by themselves. So since they're not super strong and they don't do a lot for us, we tend to talk about the other properties more frequently. The first one being the product property. The product property, as you might guess from the name, uses multiplication. However, multiplication and addition are very closely related when it comes to logarithms. This is the actual definition of the property. If you look up the property online, you just type in product property of logarithms. This is what it's going to say. Log base b of n times m equals log base b of m plus log base b of n. Here's all that's really saying. If you've got a logarithm of a number, you can split that number up and write it as two separate logarithms. You can also go the other way. If you've got two different logarithms with addition between them, as long as the base is the same, you can write it as a single logarithm with multiplication. So an example of the first one, if you have log base 5 of 60, 60 could be divided a lot of ways, but one way you could divide it would be log base 5 of 5 and log base 5 of 12, because 5 times 12 is 60. The reason you might write it this way is because, as you'll remember from that first slide, log base 5 of 5 is just 1. So you would have 1 plus log base 5 of 12. A little simpler and a little easier to work with. However, most frequently we will be going the other way. You'll take a longer logarithm, such as log base 5 of 10, plus log base 5 of x, and you would combine that into a single logarithmic function, log base 5 of 10x. And you would do this because a lot of times when you're solving for x, you need to combine things together in order to make them cancel out. Sometimes you might need to split them apart to make things cancel. The properties of logarithms are all about playing with numbers and making some of them go away by canceling them. However, you guys might guess that if there's a product property, there might be a quotient property. And just like the product property deals with multiplication, the quotient property deals with division. But just like the previous one had addition, the quotient property also has subtraction. Again, here's what it actually says. So if you look it up online, this is what you'll see. Log base b of m divided by n equals log base b of n minus log base b of n. So you'll notice it's basically the exact same thing, but we replace the multiplication with division, and we replace the addition with subtraction. One important thing to notice here is with the product property, order did not matter. Because it was multiplication, you can multiply in any order and get the same answer. And it was addition. You can add in any order and get the same answer. That is not true with subtraction and division. So make sure if you're using this property, the numerator becomes the first number and the denominator becomes the second number. For example, if you have log base 3 of 23 over 12, that's the same as saying log base 3 of 23 minus log base 3 of 12. Again, just like this, it's not super useful. You probably wouldn't use it like this, but you'll see in your homework assignment that there are a lot of times where this allows us to simplify things down and makes our lives much easier. For example, log of x minus log of 4. Remember, if there is no base written, you assume it's base 10 because that is the common base for logarithms. But log of x minus log of 4 equals log of x over 4. So we've taken a logarithmic function that had two different logarithms, and because they had the same base, we were able to combine them using the quotient property into a single function that'll make it easier to solve. The last one we want to talk about is called the power property of logarithms. It is the true workhorse of all these properties, and it does a lot of work for us. On the surface, it's very, very basic. If you have a logarithm and the number that you're taking the logarithm of is raised to a power, you can write that power out in front of the logarithm and just multiply. So for example, this is again what you would see if you looked it up online. You would see log base b of m raised to the nth power. You just bring the n out front, n times log base b of n. The reason this is so powerful is because it lets you do things like this. Log base 8 of 125. Well, 125 is 5 raised to the third power, so we could rewrite that as log base 8 of 5 to the third power. And now that we have a power, we can write it out front, and we have 3 times log base 8 of 5. Doesn't look super useful, probably, but simply by making that 125 a much smaller number, it allows us to understand what this value is close to without even evaluating it. Because we know that log base 8 of 5 is going to be a number slightly smaller than 1. Another example of this would be something like log base 2 of 64 raised to the x power. Well, 64 is 2 to the 5th power, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this is actually incorrect. I need to fix this, and I'll actually do that right here in front of you guys. Because 64 is not 2 to the 5th power, it's 2 to the 6th power. And now the people in class won't even know. Don't tell them. So essentially what we have here is log base 2 of 2 to the 6x, and that 6x comes out front because that's the power, and now we have 6x times log base 2 of 2. Well, again, going back to that first slide of definitional logarithms, log base 2 of 2 is just 1, and 6x times 1 is just 6x. So this all simplifies to just 6x. The final property we need to look at is one that used to be absolutely vital. And the reason I say that is because the change of base property says log base c of a is equal to the log base b of a over the log base b of c. Now you'll notice log base b is not on the left side of that equation. The The reason we used to use this a lot is because calculators didn't used to be able to put a base for a logarithm. They were programmed with log base 10, and they were programmed with the natural log, log base e. But you couldn't just type in log base 3 of 5 and get an answer. So if you wanted to find the answer to log base 5 of 4, what you actually had to type into your calculator was the change of base formula. You had to type in the log of the number you were taking the logarithm of divided by the log of whatever the original base was. So in this case, that would be 4 divided by 5. It became a big pain, and it was very easy to forget to do this. So calculators have evolved, and whether it be Desmos or your TI Inspire, those calculators are now able to actually type a number into the base of a logarithm. Because of that, we don't use the change of base property a lot, but it still is useful to know in a few situations. Let's take a look at an example problem from your homework of using these properties to simplify a problem and make it actually work and solve the problem. Let's say you have log base 5 of 5 raised to the x plus 6 power plus log base 2 of 256 to the third power. Well, the first thing I personally see when I'm looking at this is that I have logarithms raised to powers. That means I can use the power rule to move those powers out front. So I move that 6 or the x plus 6 out front, and I move the 3 out front. Easy enough. The next thing I see is that, well, log base 5 of 5, that's part of our definitional rule, right? Log base 5 of 5 is just 1, so that gives me x plus 6 plus 3 log base 2. But when I look at 256, I notice that that's a power of 2. 256 is 2 raised to the 8th power. So now I'm getting rid of the log base 5 of 5 by recognizing that that's 1. That gives me x plus 6. I'm getting rid of the 256 by recognizing that that's 2 to the 8th power. So when I look at this, I see x plus 6 plus 3 times log base 2 of 2 to the 8th power. Now, from that definitional slide, you guys might remember that if you've got a base and what you're taking the logarithm of is the same thing, so in this case log base 2 of 2, that just equals whatever the power is. In this case, 8. So I'm replacing log base 2 of 2 to the 8th power with 8. We have x plus 6 plus 3 times 8. 3 times 8 is 24. 6 plus 24 is 30. So log base 5 of 5 raised to the x plus 6 power plus log base 2 of 256 to the third power is just x plus 30. It's just x plus 30. Some of the problems are like this, where you won't just be able to plug it into Desmos or into a calculator and get the answer. Because with that variable put in there, there's nothing to define the variable as. However, some of the problems are just a long string of numbers. So like log base 4 of 3 plus 18 log base 2 of 2. You would be able to just plug that into a calculator. However, I strongly recommend taking the chance to practice these properties of logarithms, combining them as far as possible to get to a single logarithm, and then evaluating that single logarithm with your calculator. This really is everything you guys need in order to be able to successfully complete 10.3 now, properties of logarithms. So that is on your HRW assignment. You will have today, tomorrow, and Wednesday to work on it. However, tomorrow we do have a 5-question mini quiz, so make sure you get that done as well, and make sure you save enough time to finish this assignment completely. With that, good luck, Wildcats.